So now that we've been through our lecture, I encourage you deeply to think about what you took away and what has been new to you. What did you learn really? But more importantly, ask yourself critically, what is the stuff that you did not understand? That is very important to me as your teacher, that you really think about that, because thinking about that will actually clear up some questions that you have. And if not, it will at least help you to understand where you have to go to find more information about this. So please go through that effort. This is by far the most important thing in each lecture, or at the end of each lecture. Don't skip on these 5 minutes that those boxes cost you. That is very important. I put a lot of effort into these just for your benefit, so please use them as such. All right, so what have we learned? We definitely learned the formulas and the operational laws. We don't have to worry about those anymore. Those were derived. We can now use the scalar product, which from now on we don't call dot product anymore, properly. So we can use that and check that off. Then I believe I gave you some examples of the physical interpretation. So please keep the physical interpretation in mind and what I mean by project vectors onto another. That is our takeaway from this lecture for sure. We also saw the importance of unit vectors, especially in the context of projecting vectors onto another. So we can use the unit vectors properly, and we can describe any vector by its unit vector and its magnitude now. That is a check as well. Very important from an engineering standpoint and for your future career is to really deeply understand this fact that there's always a parallel and a perpendicular component if a force is acting on the structure. And what we did today is really to break those components down, right? So they can always be broken down into the components that we ultimately defined for you or found with you in these problems, example problems that we've been through. So that is important that you understand when there is a parallel and a perpendicular component, or more precisely, when you wouldn't have a parallel or a perpendicular component. So in other words, you understand the physical interpretation now of the scalar product, and you can use it to determine the parallel force components. That's really what we're doing here, the parallel force components. That is a problem that you will see on your exam, no question asked. So please make sure that you truly can check this off. And with that said, I believe we completed our last page of the lecture script, and we can move on to our homework problems. So let's take a look at these fun homework problems, and of course we go through them one by one. You will be very surprised how easy your very first problem is. What you ask here is to find the force that is parallel in AB due to the force F4 acting at A here. And if you really think about this, you may not have to do any fancy math. If you use common sense, you might arrive at the answer much faster than using what we've done in this lecture. However, you should obviously practice what we did in this lecture to confirm your findings and to be prepared for the method that we will ask of you in the exam. But this is a very simple problem if you think about it. If you just want to apply a method, then it is neither complicated nor easy. It's just a regular dot product problem. So please think about this problem before you start it. And you should always do that, obviously. Don't just, start because you start. Think about the implications and what it means. All right, now here we have a similar problem or a similar pipe structure that we saw before in our example. And now the force is not given to you as ijk. That's actually the only difference here for this problem. You need to find the ijk component of F3 first. This practices our understanding of the 3D angles so that you can use the ijk component of F3 to find the parallel force component in BC. So once you found that, it's a very straightforward problem, and I wish you good luck with that. No tricks here. Nothing to worry about. So here for problem C, first of all, let's look what the problem wants. It says that we need to calculate the force component along OA, so no surprise here, due to the force F4 in kips. So if you are not familiar with kip, that stands for kilo-pound, right? So kip, kilo-pound. But technically you could solve this without the units, but you're encouraged here to use kips. And F4 is in kips with angles given to you here. And be very careful, because this dashed box here shows you that this moves into the negative x direction. So the pipe goes into the negative x direction, and the force is also going away from that. In fact, you can see here this line is parallel to the y-axis. And because that's parallel to the y-axis, you see that 30 degrees actually causes the force to pull away from the positive x direction. So please be careful with the negative terms here. But other than that, I believe it is a simple dot product problem. Last but not least, we have a very interesting problem here in which you are supposed to find the angle actually. So you can use the other concept of the dot product that was mentioned to you in the lecture, where you have a position vector 1, or it's actually a force in this case, but it's really a position vector, and a second position vector. They have a certain angle between them in 3D, of course. And you can find that angle by using the dot product. Now, you see that the first force here is actually given with the directional cosines, whereas the second force, or actually the first force here, F1, is given by this 3D interpretation of these angles. And you can use those to determine the IJK components for F2 as well. And then you can find theta through the dot product. And I believe that concludes our homework overview. You should definitely be able to solve this now with the information provided in this video. I wish you good luck studying and preparing for your quizzes and exams through the homework. If you have any questions on the homework problems, please post them in the discussion boards online. Until next time, stay safe.